Hi everyone, and welcome to this course demonstrating how to use the copycat node to create effects in Nuke. In this example, I'm going to show you how to use copycat to make a garbage mat. Copycat is new to Nuke 13 and works by copying sequence-specific effects, such as beauty repairs, deblurring, or garbage matting, from a small number of frames in a sequence, and then trains the network to replicate this effect on a full sequence. If this is the first time that you're using copycat in Nuke, you may want to first have a look at the Introduction to Machine Learning and the copycat Quick Start videos, which are both available on the Nuke Learn page. And we'll give you an overview on some of the theory behind machine learning and how copycat can benefit you when working in Nuke. In this course, I'm going to cover how to use the copycat node to create a garbage mat, but remember that you can use copycat for much more as well. Mats are often created in Nuke using rotoscoping, which is a common compositing task, but it can be hugely time-consuming, and using machine learning can save you a lot of time and effort. It works by rotoring just a few frames and then applying the result to the rest of the sequence. So in this example, I'm going to use a .mov of 280 frames. You can also use an image sequence if you want. And the aim is to use copycat to create a mat of the woman running in this shot. Now ordinarily, a roto artist would spend a long time extracting this mat and would probably end up going through frame by frame and refining the roto. So the first thing we need to do is to create a data set. And a data set is a number of image pairs that are used to train the network to perform a specific task. Image pairs consist of one input image and one ground truth image. The input image is before and the ground truth is after the effect is applied. So in this example, the before would be a single frame from the sequence, and the after is a manually created mat of that frame. So when you're making a data set, you want to make sure that you have a good diverse selection of images, as this tends to produce the best results. Now, what does a diverse selection of images mean? Well, in this example, I'm going to want to choose frames where the woman has her arms in different positions, where her arms are close and away from her body. I also want to choose frames where she's further and closer to the camera, and frames where she's in front of varying background elements. Choosing diverse frames for the dataset gives copycat more information to use during the training and can really help to improve your results. Do remember that this is the same no matter what effect you're using copycat for. The dataset should always be as varied as possible. The more frames you use for your dataset, the better the result is likely to be. So in this sequence, I want to make sure that I'm choosing frames where the woman is running in front of different elements, different colors and textures in the background. I'm going to make sure that I have frames where her arms are in different positions to create varying shapes for the mat. And I'm also going to want to have a look at things like motion blur and choose frames where there's a lot of motion blur and where there isn't so much. I should also be choosing frames where not only her red jumper is visible, but also her black trousers. And the reason for doing this is just to make sure that when you're training the network, you're telling it to look out for not only where the girl overlaps with this white wall and the grey road, but also with the white lines on the grey road, the yellow lines, the leaves, and so on. So I'm going to use probably about 6 frames for this. You can't really use too many images for your dataset, but do be aware that the more frames you use, the longer the training is likely to take. But you don't want to use too few frames, as that will produce a poor result. So it will take a bit of trial and error. So now that I've chosen the frames to use, I'm going to create frame hold nodes to represent each frame and enter the chosen frames in the properties. You can also use a Python script to add these frame hold nodes to speed up this workflow. Then I'm going to add a frame range node after the read node and set the frame range to 1 to 1 so that each frame has a range of 1 and they'll follow each other in sequence. If you prefer, you can also write out the chosen frames separately and bring them back in as individual read nodes. And now I'm going to add an append clip node and add an input for each frame hold node. You can also select all the frame hold nodes and then create the append clip node so that they're already connected and you don't have to pipe them in manually. The inputs don't necessarily need to be in number order, but it can help to keep things organized, especially if you end up using multiple append clip nodes. and I'll come back to why that is later on. So the next step is to create a mask for each of the chosen frames. And for this, I'm going to use a roto node after each frame hold node. If I quickly check the alpha channel for the footage I'm using, it's completely white, which is not ideal as I want to be able to roto a mask out. So what I can do is just add a shuffle node straight after the read node and choose the full black option for the alpha channel. And now I'm ready to start rotoing the girl. I haven't refined the roto as much as I probably should, but it's enough to give us a fairly good result. And now our masks are ready, we can split up what we want to use for the input and what we want to use for the ground truth of the dataset. So as I said, the ground truth is the result we're aiming for, which in this case is a garbage map. So I can isolate the mask I just created using a shuffle node to shuffle the alpha into the red channel, and then use a remove node to keep only the red channel. Now, you don't really need to shuffle the alpha to the red channel. You can keep it in the alpha channel, but it is nice to be able to switch between them in the viewer without also switching back and forth from the alpha. And it also makes it easier when looking for errors, which I'll talk a bit more about at the end of this video. And then the input for our dataset is the original frames, so I can just add another remove node to keep just the RGB but not the alpha channel. And now we have a very clear dataset consisting of a before and after that we can use to train the network. And as with the chosen frames, you can also choose to write out the alpha channel separately and read the images back into the node graph if you prefer that workflow. Now we just need to create a copycat node and connect the ground truth to the first remove node and the input to the second. And just before I finish this video, I'll explain what the workflow would be if you did write the files out separately. You'll end up with two append clip nodes, one for the chosen frames and one for the mask. It's very important to make sure that the append clip input order is the same for the input and the ground truth. If they're not in the same order, then the images won't match up when training starts and you'll not end up with a good result. This is a really common issue, but it is an easy one to fix. If you have a large data set and it's not obvious whether the connections are correct, you can just use a merge node to merge the input and the ground truth, append clip nodes, set the merge to difference, and check that the image pairs line up. And as you can see, in this example, the images are all lining up, but if I switch the two inputs around, there's a mismatch, and that will cause big issues during training. Okay, so now we have our dataset ready. In the next video, I'll talk you through the copycat node properties, show you how to train the network, and monitor the progress.